Hi and welcome everyone to Red Hat Summit. Welcome to one of the first breakout sessions of this week. We're going to be talking to you today on managing 15,000 network devices with Ansible, what we did with the current engagement. I'm James Mighion. I'm a senior consultant at Red Hat. I've been with Red Hat for coming up on 7 years now. This is my second time presenting at Summit, both times on automation, but this time finally with Ansible.
And I'm Landon Holley. Can you guys hear me okay?
You might want to move that up a bit.
Test. Buttons. Test, test. Is it good? Okay. How about this?
There you go.
Test, test. Can anyone hear me okay? Okay. And I'm Landon Holley, also a senior consultant at Red Hat. I've been here for a little over 3 years, and I'm a Summit newbie. First time here, so if you guys are like me, welcome. So before we dive too far into this, I have a quick question. Has anybody here actually done anything with Ansible for networking yet? Just a quick raise of hands. Okay, not bad. It's actually a lot more than I thought. So I won't dive too far into the basics, but simply put, what we're doing with Ansible networking is basically just Ansible Tower plus Ansible Engine. Tower being the API and UI over Engine. And Ansible networking is, you might have guessed, just network automation modules. Anything like Windows, Linux, network automation modules, it's all the same. And then network automation modules allow you to easily begin managing your network, making network changes, and ensuring that you have a steady state of when your systems are getting their configs, having their backups performed, any changes that Ansible does, any checks performs. It's called item potency. Is that a word that anybody are familiar with?
I hope so.
Long story short, item potency means you can make changes with Ansible. You can run the playbooks over and over and over. If there is a change, it will make the change. If there is not, it won't do anything. So what we've been doing with this is essentially creating network automation roles that are constantly running, constantly seeing if they need to make changes. And if they do need to make a change, they do. Otherwise, it just skips right on. So what we've been using with Tower is the scheduling of tasks to ensure that your configs are where they need to be and when they need to be there. And that's all done by turning your network into code, which is not nearly as difficult as it sounds. We'll get into that here in just a minute.
And another benefit from turning your network into code is over time you have that revision in history in your SCM choice that you can actually see your network progress over time.
So first thing to point out is this is automation for network engineers and created by network engineers. We're not trying to replace or put anyone out of a job. What we're doing is enabling people to more easily automate and manage their network. As you probably know, networks have been around in their current form for quite a while. They're not going anywhere. These are problems that have been around for a long time and will continue to be around for a while. We think this makes things easier. We think it will help you easily automate your environment a lot better than you currently can. But again, we're not trying to replace or put anyone out of a job. This is a framework. You can build anything you want with it. You can automate your network however you need to. But it is pure and simple a framework. The entire purpose is to modularize everything you want to automate in your environment. And more importantly, anybody can pick this up in no time flat. For those of you that have worked with Ansible already, if you've been building any network automation roles, you're probably familiar with the syntax being roughly the same as you would expect to see with Linux device, a Windows device, cloud device, anything else. Anytime you're doing any network automation, it's going to be basically the same syntax, and that allows you to quickly get started and then immediately just dive right into something else.
Ansible syntax.
Ansible syntax, right. But most importantly, all this network automation needs to be built by network engineers, the people who know their networks, the people who know their configurations, know how their devices need to be, where they're at, all of that stuff. If you are doing any network automation, and if you were the one building it yourself, you will get a lot.
My bad.
Okay. Anyway, if you're a network engineer, you need to be building this yourself. You will get the best results that way, and you will learn most about Ansible and how your network can be automated the most efficiently. So let's take a quick look here. I guess a lot of people get started with this thinking, is it easy? As you can see here, yes, this is very easy. We have two playbooks on the left here. Or we have two playbooks up here. The one on the left is just doing a simple show run. That's going to grab every config. Well, we have it targeting all hosts. So running this little playbook will get every config in your environment. As you can see, we have a connection set up to use the network CLI connection, and we're logging in with the admin user. Pretty simple. And then the tasks below, the iOS command simply logs in, does a show run, and sends you the output. Now, the playbook on the right is more or less the same. We have it targeting a particular router, or I guess it could be a group of routers if you want. Again, network CLI, admin user. This one, similar to the show run, where it sends you the full output, this one simply backs it up and saves it to a different location. Makes it very quick and simple to dive right in and have all your configs from every device in every environment, or have your devices backed up to a location. You can get started doing this in just a few minutes. More or less, it really can be that simple. So the way we started building all of this is with roles. Every playbook, every task, even every single command, we did a role-based approach. And roles are more or less just a way to allow you to group a reusable set of playbooks or tasks, something like that. We grouped every role, like for instance, AAA, syslog, everything that performed a particular function against a particular part of the OS or the network device. We split apart everything into separate roles. Even for one-off commands like ad hoc commands, you know, we just want to show the version or check the time on the devices. Create a role for that too. And it makes it very easy once you have some sort of role set up and a tool like Git, where you can just have anybody and everybody working on those devices and in these environments, all collaborating and building out everything at the same time. We had the network SMEs, we had the network engineers, and we had us as consultants all working on the same projects, the same roles, and nobody was stepping on anybody's feet. Worked out very well. So how does it all work? So first off, with network automation, it's a little different than with Linux, Linux, Windows, or traditional OSs like that. Ansible Engine and Ansible Tower operate entirely locally for the most part with network devices. And the key differentiation there is network automation runs commands against devices, but the devices themselves often don't have any ability to do their own processing. For instance, if you log into a Linux server and run a syslog playbook or something, all the commands get sent to the device performs its own changes, and then sends back the results. With network automation, however, everything is performed locally for the most part. Ansible will issue commands, the devices will receive those commands, take the output, send it back to Ansible where it does most of its local processing. And then it sends more commands back to the device to make the final changes. So the first thing we ran into with this is that because everything is running locally, you know, it's just a different way of having to think about Ansible. So yeah, rather than devices being able to do their own work, you know, if they have Python or Bash natively, and some newer network devices do have APIs as well, which does make things easier, and even fewer have Python and Bash. But either way, everything we did with this approach for targeting 15,000 devices was all command-based. Short from F5s and a few of those.
Yeah, all over SSH.
Yep, all of it SSH, all of it just basic iOS commands, iOS config, stuff like that. And on that note, I'm going to turn it over to James here. He'll talk to you a little bit more about the project in depth.
All right, so for our project, we had a couple key sets of goals. We needed to target multiple vendors and a wide array of versions in those vendors. As you can see here, Cisco being the bulk of the inventory and the types, with roughly, I think, 9,000 or so being Cisco iOS and XE. We also had some wireless controllers and load balancers in the mix as well. And the one key point here was this was all for an internal brownfield network. We also had some manageability use cases to help provide consistent configurations. The goal for this was to help reduce the number of hands on keyboard actually logging in and making device configurations. We wanted to reduce the number of network engineers actually physically touching these boxes and move this to an automation sense. Another large part of this engagement was also teaching the team a lot of things like agile practices with Scrum, sprint cadences, some Git training, release cycle stuff, and Linux basics. And then another big part was also fleshing out, or helping them to flesh out, a source of truth for their configurations. Here you can see a architecture layout that we had. It's pretty standard for the most part. We had a 3-tower cluster, although one of them did not make this picture, but all of them had a 3-tower cluster with a second database set up with streaming, Postgres streaming replication enabled for backups, and if we needed to manually, or actually we had the automated role to switch it over on the offhand chance we needed to. We also had a lot of normal custom stuff, or normal things that you see, LDAP. The client had a private GitHub that they hosted locally, and custom CMDB, which is where we pulled all of our inventory information from. That was a very crucial part, that we were able to write a script against their CMDB, which had an API for us to pull back a lot of great information for us to work with and populate that as vars. We had this same setup across the board, so the same specs for UAT and prod, but with a smaller spec setup for dev, and then an even smaller dev, kind of just offshoot to do dev. So for the approach, let's start with the repository, for the Ansible repository that we hosted on their GitHub. It's pretty standard, as the most part. A few key things here to take away is we had some custom modules in the library, and a lot of custom plugins, action filter, lookup, terminal plugins. But the bulk of the work, like Landon said, was done in the roles. And here's a small sample of some of the roles that we created for the client. Most of them around the manageability aspects, trying to maintain configs across all the devices. They were, as you can see, mostly one service per role. So like you said, we have like config NTP, config AAA, and ACLs, trying to keep those as modular as possible. The network CLI and network engine roles here at the bottom are provided from the Ansible network engineers. We use these two to help parse out facts from the network devices into a vendor-agnostic data model based off of OpenConfig. But then the last one there is network facts was our custom, well, all of these were custom, but this was a custom role for gathering facts for their original data model set that we used as a dependency for pretty much all of the rest of these. So facts were a crucial part and very important so that we could gather as much information and reuse them throughout the lifetime of a playbook, touching as many roles as we needed for whatever the case. So if we had a workflow in Tower, like we did for setting up certain, like a local password followed by SNMP changes, those would all still start with the facts. We need to get the facts first. All right, so let's look at one of these roles. Here is the config SNMP role. As you can see, it and actually most of the others had a lot of the basics, some default vars, the handlers, information in the meta to point to that network facts role as a dependency. But one thing here for these files, these were just for F5 and there were parsers. We found that it was easier to get at the information from the output of F5 with the parse CLI filter that the networking team has made. And we run with those in the F5 specific task. So here are some of the tasks inside of this role, and pretty much all of our roles look like this. We have a vendor-specific task file for each vendor. In the future, we're going to try to be moving towards a more vendor-agnostic modules. Those are already available right now. We just hadn't had the time to go back and refactor all these. But when we do, we'll be able to collapse some of these to more consistent configurations if possible. That's not always possible because of the syntax differences across the board. But we would be able to see less work being done in the vendor-specific ones once we start implementing the more vendor-agnostic roles or modules. So with that, those would end up being, the vendor-agnostic ones would end up being in the main file. So let's take a look at this main the main task file here. That was it. So as you can see, it's very simple. There was not a lot going on here, but the key takeaway is the bulk of the work is driven from this device OS var. And this device OS var is literally just which vendor am I? And this best place to get this from is from your inventory. Thankfully, in our situation, the CMDB that we had to work with had that already populated. We were able to pull that in. So every host that's coming through, when it hits this role, it starts here and says, who am I? Okay, I'm going to go, if I was like an iOS device, I would end up at a Cisco IOS task file. So do note this is a very simplified, watered-down version of this because we had to strip out a lot of things, and also the task options that we had in here were a lot longer because it's YAML, and we can fit on a slide, but a couple of key tasks to talk through here. So in our case, most of the config lines were pulled from group vars. Since they were consistent enough across the board, that was a good starting point. So for iOS or whoever, we had a group var for, in this case, like getting the SNMP lines. And then in these task files, that's where we can take the vars that we've gathered along the way or we get from the inventory and do some vendor-specific things like determining what lines we need to add based off of version or modeling or location-dependent things. So we're not stepping, so the configs in Dublin aren't the same as the configs in Cheyenne. So for this example, for the 6500s, we knew that we just needed this one config line added. It needed to be in there somewhere. So we're just adding it to the lines, the baselines that we have set up for SNMP changes. And what we're doing here is only applying this. We're doing a quick just version compare based off the first two numbers of the model number. That model number is a gathered fact from that network facts role that I talked about earlier. You can also grab this from your inventory if it's in your CMDB. Ours we parsed out from the devices themselves just to make sure we had everything correct. So nothing was crazy was going on in that first step. So, but then we would have a lot of tasks like this, adding or editing lines as need be. But then once you get to the point where you're ready to run them, you simply just send all of these lines to iOS config. So let's talk about this. Let's just break this down real quick. The first thing here is this provider object. It's a bit different than those first examples that Landon had showed you. This is the ever so slightly older way of doing it. What we're passing in here is a dictionary called CLI that just has the username, host, password, and any authentication information that's necessary. This is still viable. The other way that his example showed, we're using the new connection type, which is network CLI. We just haven't. We were working with this before. That was an option. We again have yet to go back and refactor everything, but both are functional and both will work. The most important thing here is this next one, the running config line. So with this, we're passing in config here, and this is another gathered fact that we did in that network facts role. So we hit the device, did a show run, and then we're passing it back to the module so that the module can avoid going back to the network device and doing another show run to determine its item potency checks. Here we're saying, here's the config I want you to do your item potency checks against. Use this. And this was a key add for us for making sure that this scaled out well. Because otherwise, when you start hitting thousands of devices at a time, there's a lot of network chatter, a lot of overhead, a lot of computational overhead on the devices doing show run all the time. And this avoids all of that. So as long as you're in a state where you can pass in a good enough version to do your item potency checks against, I would highly recommend this for building this out at scale. And then the lines is simply the SNMP lines that we started with and made changes to along the way as needed. And here we have a parent section. We left this in as an optional thing for the network engineers to use from Tower in the case where they needed to specifically hit some specific parents or a set of parents. So it was just a survey that we had set up, but if they didn't fill it out, we would default it and omit it. And then this last line, save yes, that's the one that finally tells the module, go in and do the save show running config to startup config. All right, so Landon, networking scale.
So how did we actually scale this out to target 15,000 devices? So first thing to discuss is that regardless of what you're doing, the number one thing to look at is the config size. So for all the devices you have in your network, literally the raw output of whatever commands you're running on those devices, show run all, anything like that. For instance, we had some iOS devices that averaged around 50 to 100K. If we had 10,000 of those, as you can imagine, that can produce quite a bit of memory usage. So the second thing we had to look at was device performance themselves. So individual devices perform more or less quickly than some other devices. More or less the end-to-end process of logging in, running the commands, the devices processing, sending the commands back. Ansible would then inspect and make its changes and then resend new commands. Depending on how quickly those devices perform, again, more or less quickly, it could vary. It will vary. Third thing we looked at was the actual inventory sizes and the device families. So for instance, iOS, NXOS, XR, some of those, all of those we ran commands against largely at the same time. Uh-oh, hold on. Okay. Yep. So iOS, XR, NX, all those. Due to large inventory sizes of these and due to the significant inventory metadata, we had to break down all these inventories into much smaller inventories. And what I mean that is, so we had 10,000 iOS. We broke those down into much smaller groups, and then we had those running more frequently as opposed to just one giant group that was slowly running in the background. But that's also dependent on, again, the devices themselves, your network bandwidth, processing abilities. Because everything is running locally, again, all of that is very dependent on your local environment and your local resources. Another critical thing to look at was how frequently we were making these changes. So again, as I mentioned a minute ago, all of these devices have the potential to perform more or less responsively. When we first got started, we were trying to make lots of big, frequent jobs that would go out and scan the network for any changes that we need to make. We ran into a lot of issues, a lot of scale issues there because we needed to break those down into smaller groups, smaller inventories, smaller playbooks, that sort of thing. Once we started targeting those, we saw much better scale. We went from being able to run maybe hundreds, thousands of changes a day to tens of thousands of changes a day. And that significantly increased how quickly we could run everything. And then the last big thing to think about was the use or availability of Ansible facts. As we've covered a couple times, Ansible facts are just vars. Useful vars, useful parts of the config that we pulled out and then reused later. When we first started targeting all these devices, we were just running command after command after command and letting all the results come back. That took forever. So what we started doing with this, again, reusing our code. If the config came back once, we just stored that as a var and then compared that against all the future changes we were going to make. That saved us a lot of effort having to, again, wait for all these commands to go, come back, changes to be made, all that stuff.
One other critical point here for the network facts is for the networking side of things, the fact gathering for Ansible network automation is different than standard Ansible. In standard, when you log into your remote host, it's able to execute and run your fact gathering stuff. That's not available here for the most part for networking devices. So that's why we had those roles that I pointed out at the beginning, because we had to go make that ourselves. We're getting to the point where we're going to be able to release that and have that more widely available as parsers in the future, because that's going to be needed across the board.
Yep. Thank you. So the second part of this is looking at the inventories and the jobs themselves. So now that we kind of understand how Ansible processes, for the most part, everything locally, we can actually start to spec our tower clusters. So again, key point here, everything runs locally. So the biggest change we saw was adding CPU resources. For the most part, when it comes to pure processing, more CPU equals faster processing. I know it kind of sounds redundant, but the one thing we found out was that early on we started using some pretty simple VMs that really didn't have a lot behind them. Once we upgraded those, we saw tremendous improvements, pretty much linear across the board. The more CPUs they add, you will more or less double your processing capabilities.
And that's because it's all running locally. It's all the local connection information. So all the brunt of the work is happening on your control node, your tower host.
Yep. And then the second thing was, again, I mentioned earlier that when we first started this, we were trying to run everything in these big jobs that just ran forever and didn't really get us the results we were wanting. So first thing we did was make smaller tower hosts. We had a few big tower hosts originally, and what we need to be doing is having a smaller group, as many resources, but broken out into smaller VMs or smaller servers. Just simply due to the way that Tower performs its changes, it doesn't know ahead of time what changes it'll be making or what exactly it'll be doing. I'm sorry, Engine and Tower. When you first run any playbooks, it will know what those playbooks are, but it doesn't know what results to expect from these devices. It doesn't know how long it's going to take for all these devices with their latency, with any network bandwidth. For the whole end-to-end changes to occur, Ansible and Tower have no idea what will be happening. So we broke everything down into smaller inventories, and we set up job limits, and we set up lots of smaller jobs instead. So again, earlier, I was talking about the bigger jobs we were running that were just slow. Smaller jobs, smaller inventories, smaller everything for the most part.
Forking as well.
Right. Also, forking the jobs. We started somewhere closer to 500 to 1,000 forks, and we saw very quickly that lowering that number to 50 to 100 lets Ansible, Engine, and Tower do a lot more processing, again, depending on the devices, depending on your environment, and depending on how much processing power you have. So the last thing, again, facts and fact caching. This is probably the big one. We've mentioned it a number of times, but the more you're able to use or reuse your code, the faster you'll be able to process and make changes. It's that simple. Please use them and use the fact cache. I put a nice big picture up here because that's it in Tower. Click the button. It will make things easier. So on to some actual results. First thing I want to point out is there's a big difference here between these iOS, XR, NX, EOS, and then the all at the bottom. So first off, these are all, for the individual runs up here, these are all targeting 500 hosts and set to 100 forks. So we were able to run fact collection against 500 iOS devices in roughly 4 minutes. Fact collection against XR in roughly 4.5. You know, NX, EOS, you see that. So the all at the bottom is how long that took to perform those, the fact collection in the entire environment, which for us was roughly 2 hours for 15,000 devices in Engine with the hardware we had. So that's the key performance indicator there. If you have more hardware, you will make these changes faster. If you have less hardware, it'll be slower. Pretty simple. Everything runs locally. That's the takeaway of all this. Contrary, again, to how Linux and Windows and all those work, everything runs locally. Similar with local passwords and the community string changes that we did, we based all of these future roles on fact collection. So more or less, fact collection is occurring with every run, with every change, unless it's cached. So with local passwords and SMP, you see some additive times on top of that. Local passwords is pretty simple. We're just making a few quick checks to ensure that the configs are in the state they should be before, and then we send the command to run new passwords. Not too much complexity there. SNMP string changes, we do a lot more database calls to perform more checks against back-end configs and that type of stuff. So additive onto that, it took us roughly 2.5 hours for local passwords and 3.5 hours for SNMP community strings. Again, and all those built on top of the others. So fact collection would run first, local passwords would run second, and then SNMP community strings would run third. All set up in Tower workflows. And I'm going to turn it back over to James now.
So new development-wise, throughout the course of this engagement, we developed and fixed a fair amount of things, everything being upstreamed as much as we were legally allowed to. So early on, we knew that we needed to work with some wireless controllers, so Aruba and AirOS. So early on, we developed the command and config modules for them and all the necessary plugins that they need. We also added a new save option as well to most of the core network modules, save when changed, which just executes a save only if during that actual task there was a change that was detected during the idempotency checks. So for our client, we needed to communicate over SSH always. We weren't allowed to use any of the APIs. So for F5, we needed to develop a way to communicate with the F5 devices with Ansible Network over SSH. So we took their big IP command module and added a CLI transport option. It's the only one that has that at the moment because most of their focus, or F5's focus for their Ansible modules is to do it over their API, but that just wasn't available in our environment. So thankfully, we worked with F5 one-on-one with Tim Rupp, who I believe is here presenting later this week, and got that added. We also had a bunch of other minor fixes that you always happen across documentation, some connection setup things, and multiple changes in the Ansible network repos, the ones network CLI, network engine that were recently provided by the Ansible networking team. Also, there's a few more to come in the near future. We have some changes for PanOS modules, some terminal plugin fixes, and a lot of parsers that we're in the process of trying to get cleaned up and upstreamed. So on to some of the challenges and lessons learned. Starting with challenges, first and foremost, we had limited hardware. We quickly realized that with everything running local and trying to do this at scale with all 15,000, we needed to spread this across more tower hosts, and we just needed more resource-laden VMs. That sadly was not available to us. We hit our capacity with what we had available, and we had to work with what we had. But we have learned from this, and going forward, we have been telling new customers and new clients much more information about how to spec these clusters better for Ansible network loads specifically.
Question about that?
We got QA real soon. Okay. Yep. Another challenge was the variability that we had. A lot of devices in a wide variety of versions. Some older, some new, and that made us do a lot of logic checking and a lot of config building in the tasks, like the vendor-specific tasks themselves. Training and focus. The networking engineers that we had to work with were not very familiar with Linux or Git, so we ended up doing a lot of teaching, a lot of training, along with rolling out what we needed to hit their use cases. Also, Ansible Network is fairly new product as a whole, so there was a lot of new information for everyone to be absorbing. But that's not a slight at the network engineers that we worked with. They're brilliant people. It just seems to be more of a general growing pain for that industry as a whole, as network automation still seems to be playing catch up to server-side automation. Oh, also the team had their normal day jobs like everybody else, so their normal responsibilities didn't change when we showed up, which would be great. So obviously, if you had a dedicated team, your rollout would be quicker and smoother, but everybody has their responsibilities. Scaling, like we've talked about a lot, we've already covered. We had some devices that we were not allowed to touch, or very limited amount of changes. High touch, very high important devices. So we just had to work around those as much as we could. Defining a source of truth. So having a source of truth is crucial, and it showed in this. We've been pushing for this more and more going forward, making sure that we have access when we hit the ground running to golden configs or a source of truth to work from. Some of the times when we were doing this, we would hit situations where we were asking for a golden config. How do you want, what is your network supposed to be here? How is it supposed to be configured? And that information either was not available or the teams were debating on what it should be. So from lessons learned from that, we learned more about effectively scaling Ansible and Tower. Some of the logic, adding and checking for all the versions and syntactical differences between them, all the wide variety that we had to work with. Implementing the creative logic, and using facts and caching. So
please do.
Sorry?
I said please do.
Yeah, please do. The biggest part here was for the efficiency, and came from the facts, pulling the config, reusing it as much as we could without going back to the device as often. So from here on, there's a wealth of documentation and information to get started with Ansible Network Automation on Ansible.com and docs.ansible.com. We also have some training material, Linklight, which is a fork of the Ansible Lightbulb project, which I'm sure a lot of you are familiar with. And as always, we're available on IRC in the Ansible Network channel. Don't miss some of the other Ansible and management sessions that's happening this week. I think after this one in room 2014, the Hybrid Cloud Network Interconnect is being hosted by Peter Spergata, the principal engineer who built the Ansible Network Automation.
Thank you, guys.